Okay, so back 2 years ago, AWS launched a solution that is trying to address how to run secure multi-account strategy on AWS. I don't know if you guys are familiar with AWS Landing Zone. Um, it includes more stuff. I just decided to put only one architecture diagram that talks about the core accounts and how to set up at least 4 accounts to run in a multi-account strategy. This solution was pretty successful, so AWS decided to build it as a service, right? And last year they launched the AWS Control Tower, which basically looks something like this. It's exactly the same landing zone, but includes, now is offered as a service and includes a little bit more capabilities that they initially had in the solution. Working with customers, we got some feedback, and I wanted to put here only just 3 the key issues that we've heard from customers, right? Where one of them is AWS single sign-on is a required service, but we're working with some customers that they actually don't want to switch their existing SSO solutions, like Azure AD, Okta, or Ping Identity. So that's one of the like pain points that we came across. A second one, I would say, right, although CloudFormation recently added capability to import existing resources, the implementation, AWS or automated landing zone, you can call it anywhere you want, still doesn't support a very easy and flexible way to import those existing resources. Last but not the least, some of the customers that we've worked with, they adopted Terraform, they go this as a strategy, they don't want to use other infrastructure as code solutions, and that's why they actually really disconsider, well, sometimes they disconsider saying, look, this is out of scope, we don't want to adopt this solution because it's not written in Terraform, it's in CloudFormation. Yeah. So my name is Eugene, I'm a CTO at Mita Group. I'm used to, well, ex-AWS, Hearst, Grubhub. I'm a certified solution architect with over 20 years of experience. In IT, the last 10 years focused on the cloud. My area of expertise is automation, DevOps, and serverless, and I'm coming from a development background rather than operations. So today I would like to talk to you about the Terraform module for AWS Landing Zone, and I want to walk this hands-on, right? So I'd like to dive a little bit deeper into the ALZ's providers. What does that mean? Components of the ALZ, so it being a very flexible solution, you'll see that you have a lot of choices. How do you use TFVARs? Instead of actually making changes to your Terraform configurations, we consider the Terraform configurations being some immutable resources, and everything that needs to be variable, we put in the variables, right? Last but not the least, I want to show you how to, well, it's optional. You can change the backend for this solution. You can have it locally, or you can use a remote backend like S3. And if we have time, I would like to do a light demo to show you in action. So if you open a browser and you type that URL, that's what you will see. If you scroll down a little bit lower, you will see something like this, right? How to get started. So I will take that small snippets of code from the top, and I'll try to dissect this, right? So what is the anatomy of an landing zone module's structure, right? What is the anatomy of the landing zone module? So it's published in the Terraform registry, so that's how you specify the source, right? Then you have 2 required variables, which is the list of providers and list of components. We intentionally decided not to mention them as modules, but to rename them components, and I'll talk about that at the end. Last but not the least, as I said, it's an optional thing. Terraform backend, by default, it uses the local backend, but if you want to use a remote one, you can customize it as well. right? So let's dive deep into each of these variables and components of this module. Right. So what's important to understand, because we are managing multiple AWS providers, AWS accounts, right? And provider from a Terraform perspective, it's actually an account plus one and the region, right? You can have the same account to different regions, like we have several customers that they run the infrastructure on Virginia and in Oregon. That's two different providers from a Terraform perspective, right? So landing zone provider, that's the variable that is defined in the module itself, right? And this is the structure of what do you need to specify in order to have a provider that will be used by the module, right? So default is required, right? So you have to have at least one master account from AWS Landing Zone solution. Actually, let me pause a second and see how many of you are used or heard about AWS Landing Zone. Okay, around half of the room. All right, good. So the master account, that's what we consider the default account, right? And you need to specify here at least the account ID and the region. Account ID is enforceable for security reasons. It's just to make sure that in case you have in the environment defined credentials that are not from this account, right? It will force you not to execute. It will give you an error saying you're not allowed to use this account. Right? Then if you have additional accounts, right? Right now, because of the space, I put it only one account, but you can imagine that you can have the core account for security purposes, as well as core account for logging, core account for shared environment. So those are the 4 core accounts that are required by AWS Landing Zone, right? And as you can see, I put it another account number. These numbers are invented, but the region also is different to show you that you can specify different variables, different configurations, and it will work for this module. Right? What's important here is that the name or the key name of the variable is actually used later into your TFR files. So that's why you need to name them properly so it's suggestive, but as well as make it sure that you don't put some extra characters that are not allowed by the environment, by the variables, Terraform variables. All right. Okay, so let's go into components. So that's what I was mentioning, that we actually made an approach of kind of like a microservices architecture. We tend to get only one resource per component. So that's one approach. And the second approach is we are building immutable Terraform configurations. So you don't need to make changes to the Terraform itself. You only make changes to the variables that is the definition of the TFRs, right? So again, this is the modules variable that is defined. You need to define the component's name, and then where is actually the TFR file is located. Right? Well, obviously, if you don't specify a path, it's considered to be local, right? In the same directory where the component resides. You can also have these variables sitting on an S3, right? And so it can be local or remote. But also you can have one or multiple TFR files, right? For example, the demo that I'm planning to show, we have more than, so you have 4 or 5 accounts. Yeah, 4 or 5 accounts, more than 300 resources. So to define the variables for each of those resources in one file, it's kind of a couple of thousands of lines of code, right? But we're dividing them by account, and we're dividing them by some of the use cases. So it looks a little bit more reasonable, and it's not thousands and thousands of lines of code. Okay, TFRs, right? So now that, as I showed you before, you have the default TFRs. The next slide is how one of these TFR files should look like, right? So the first thing that you need to remember that in TFVARs, we also allow you to define the providers. So for example, in the module, you define all the providers that you can use in a specific component. But in the component itself, you are defining which providers actually you are using the component. So for example, when you have to manage the AWS organization resources, you don't specify all the accounts because the AWS organization is just in one account, in the master account, right? So you'll have only default, like in this example, I am referencing to VPC, but when we're talking about VPC, you obviously want to build a baseline for all of your accounts and what kind of VPCs you'll have in each of those accounts. So there you'll have multiple providers also that reside in the first line, right? So here is the list supported by the current component, right? Next is you're defining, you see that then the name of the variable is actually default provider, right? So that's the provider key name that I have in the first line, default, and then underscore provider. So that's an established naming convention in order to allow us to be able to programmatically pick up everything that you have in TFVAR files. Next, if you go into the resources, as I said, you can have, usually we tend to have only one resource per component. Sometimes it might be 2 or 3. It depends on the component. So here you will be specifying the component, again, the key name, and then underscore resource. So that's the naming convention. And going one level down, here is you defining the configuration for a specific resource, right? So I can have in my default account, I can have multiple VPCs, right? So that's why what we do, we actually iterate through all of these variables. And that's why you need to have at the end _0, _1, _2 in order to make sure that the count goes through each of them and picks them up, all right? Last but not the least, these are the key values that you actually have in this resource that is VPC resource. This is the Terraform native. Everything that you write in here is passed directly to Terraform specific resource. And if you don't specify correct value or you have some error in the definition, it will basically fail. Okay, so we talked about, well, last but not the least is the backend. This is very simple and straightforward. This is a default value, right? So if you don't specify anything, it will pick up a local backend, and this is the path, which is actually a prefix. It appends at the end the component name and then terraform.tf state. But if you want to customize it and store it in S3, this is how would you use, instead of backend local, you write backend S3, and then all the values that actually are specified in the config configuration, you can put them over here, and they will be passed into the backend Terraform for every component. Okay. So before I jump into the demo, I want to point out that one of the things that we've done here is we are iterating through providers, right? So we have one component that is defined for all the providers, right? It doesn't matter. Let's say, like I had an example, previous example, VPC, right? We have just one component defined for VPC. But Terraform natively doesn't allow you to iterate through providers, right? Because provider from a Terraform perspective is AWS is one provider, Google is another provider, right? But our solution is intentionally adding this capability because for us, a provider is just one different AWS account in a specific region, right? So that's why when you define the component, you write only once. But when during runtime, when it gets executed, it will generate one resource for every provider that it finds in the definition of component. TFVAR that is associated to the component. Right? So actually, so now it's time to jump to a demo. Before I jump to the demo, because I always forget for the last slides, so I'll just show them now and then jump into the demo. So we talked to the we talked about the modules providers, we talked about modules components, we talked about TFVARs, Terraform backend. I'll jump next into the demo, and I will leave it over here. And let me go to here. So this is the URL. I hope everyone knows and uses the Terraform registry, right? You can go directly here, right? And you can landing zone, and you'll have this one, right? And you can go read the documentation. I will jump into my terminal. Let me see if I still have connectivity. All right, perfect. Okay, so I think I upgraded today to the latest version. Okay, by the way, guys, can you see in the back? Should I make it bigger a little bit? All right, so let me do like this. Is it good? All right. Okay, so my code main.tf, right? It's that, as I mentioned, the only thing that I've done here, I changed the source. I'm referencing to it locally. It doesn't pull up from Terraform registry. And everything else is what I showed you before. Okay? Now I have Terraform TFVARs, right? And let me see. Let me think if I should show it or not. No, because I have all the account IDs already specified there. Yeah, no, you're right. Let me show you an example, right? So let me take this one, all right? So this is a pretty big example that includes a lot of that includes yeah, I'm in a screen environment and I cannot scroll up. Anyway, you see different components, right? This is the component name, and this is the path where the TFVARs are stored. You see that I'm using actually star TFVAR. As I said, I have 6 accounts, and I created for every account a separate TFVAR, right? That's actually a small footprint. We have customers that they have a couple of, so 45 accounts running in 3 different regions. So yeah, that's 106, 20, 140, right? Something. Anyway, and that actually also helps you with being consistent across the board, right? When you need to spin up an application that has to be globally, that has to be available globally, right? That's one of the things that helps into managing everything in one place. Right? Last but not the least, I talked to you about the providers. Here are just 2 providers that are defined, and the Terraform backend, the way we've set it up. In this bucket, this bucket is actually publicly available. You can download everything from that bucket and take a look what we created as examples. And let me start doing Terraform init. Okay, Terraform plan. And the Terraform plan will show account IDs. Let me do apply right away. Okay, so again, I'm not scrolling up, but you can, you should know that you will see the account IDs before the list of components, and that's how the module knows. It takes the list of components, it takes the list of accounts and backend, and compiles that as a hash in order to see if you're changing something, right? and if you make some changes in the list of providers or components, it will ask you to make updates. If you make some changes in the TF-var, Terraform will not be able to pick up automatically. So we'll talk about that next. So I have 5 resources that will be created. I'm doing yes. So you can see from the outputs that some of these are shell commands, right? Creating the environment. And some of these are these errors or done. Right? So we're using an automated tool or Terraform automation tool that actually also we build in-house that allows us to do those things that I mentioned before. First, iterate through multiple providers without actually writing every resource for every provider. Right? Second is to be able to pick up TFVAR files not only from the local environment, but from remote environments, right, like S3. And third is to be able to make connections between the components. So for example, I have subnets. I need to create subnets, right? But subnets, I cannot create subnets if I don't have VPC, right? So in Terraform, you have the dependencies that you put between them. Here, because we consider them immutable, but we also consider them independent from each other, we need to have the connectivity between those two to say to the automation that you need to create VPC first, and then you create the subnet second, all right? So everything that it does right now is just configuring. Like you can see that it says landing zone config. It's just creating the environment for the configuration. Now it starts to do the apply, landing zone apply. It actually now goes through all of the components that I have defined. Right now, for this demo, I made a subset of components. I think I have 12 of them. And that takes a little bit of time. But, oh, I think it's done. Yeah. Because I already have this environment created, right now what it does, it returns for every component. It says infrastructure is up to date. You will not see anything different than you would do. One thing that I'm not showing here is that if you already have the resources, right, how do you make sure that the landing zone module loads those resources similar to Terraform import, right? So because I don't have time, that's out of scope. If you are interested, come see me after the talk. So I hope it will be done. Sometimes it takes a minute, sometimes it takes 5. It depends on the connectivity. And by the way, we're running all these jobs in parallel. So the automation, based on how much CPU is allocated to my computer, will run 8 different threads in parallel. When you start having even less than 8, but from time to time we get errors from S3 when we're using remote state because it says it returns some issues, and that's also built into the automation tool. That when it picks up an error from S3, we are retrying that particular step. Right? So automation means it runs Terraform init, Terraform plan, Terraform apply, one after another. Let's say Terraform plan fails, right? It doesn't start with Terraform init from the beginning, but it retries Terraform plan again, right? Okay, so I was hoping that during the demo it will finish, since we are a little bit running out of time. Oh, I think it provided some feedback, but anyway, I hope it will be over before if there are any questions. Yes. Yes. But
Eugene, can you repeat the question?
So the question was if we basically rewritten the CloudFormation template. I said yes, but now I need to think about it and just rephrase. It does change. So the CloudFormation template is not in a microservices architecture, right? That's why it's very, very difficult to replace one component, like I said, SSO, to replace AWS SSO with something else. For us, it's actually very, very easy because it's a component we are not including in the components list, and we're including our custom made that we've done for Microsoft Azure. But it, why I said yes, it basically gets the vast functionality that the CloudFormation provides. It is written in Terraform, as a Terraform module.
Any other questions? And it finished running.
All right, and it still shows the accounts IDs. All right.
All right, yeah, I think we're done.
Yep,
Cool.
thank you very much.